I'm Liesel Ehlers. I'm going to present a lesson on mathematics, NCV level 4. And for today's lesson, we'll be looking at integration. Our previous lessons were based on differentiation. We were doing differentiation, so I'm going to start exactly there. That's something that you know. So let's say I ask you to differentiate the following: y is equal to x cubed plus 5. So the derivative will be, you take the exponent 3 to the front, x to the power whatever you had minus 1, and you will remember the derivative of a constant was 0. So my answer will be 3x to the power 2 plus 0, or you can just say 3x squared. So now let's say I want to know if the answer of differentiation is actually 3x squared. What did I start off with? Let's write this as 3x squared plus nothing, okay, because 0 is nothing. So if I want to know if the answer of differentiation is 3x squared, what did I start off with? So 3x squared was the answer of differentiation, and I want to know what I started off with. In able to do this, I'm going to integrate. So the sign for integration is this sign, and the differentiation was with respect to x, so the integration is also going to be with respect to x. So the integration rule, we are going to work through it, but I'm going to basically tell you what we are going to be doing is I'm going to actually write down the constant, and then I write down this x to the power whatever I had. I'm going to add a 1 to the exponent of the x, and then I will divide by this new exponent, which in this case is 3. And I'm going to say plus a possible constant, because remember, when I differentiated, the derivative of the constant was 0. So I could have actually started off with a possible constant. So this 3 will cancel with this 3, and if I simplify this, I'm going to end up having x cubed plus a constant. Let's check. So if the answer of differentiation is 3x squared, what did I start off with? I say we started off with x cubed plus a constant. And what did we start off? Yes, we really started off with x cubed plus a constant. I can't really know which constant I started off with because the derivative of a constant is 0, but I could have started off with a constant. So this process that I have just done here will be known as integration. So integration is basically differentiation used backwards. It's the opposite of differentiation. So we are going to look at some integration rules. There are more integration rules on your formula sheet, but we are going to start off by looking at the first 3. The first one saying, if I have an x to the power n, what should you do? You write down the x to the power n that you have, you add a 1 to the exponent of that x that you already had, and you divide by this new exponent, which is n plus 1, and you have to remember to say plus a constant. If I had k times a x to the power n, you can actually take out the k and just integrate the x to the power n, which I can do because I've got a rule. And then the last one that we are going to look at, the last rule, is if I've got more than one term in terms of x, and I want to integrate all of these terms, you can actually integrate the one, and integrate the other one, and just join those answers with whatever sign you had originally. So let's take them one by one, and we actually do some integration problems. The first question that I have is I have to integrate, and let's say now from the start, if we get our answers, it may be said that you must give your answers with positive exponents and insert form. So we are going to give all the answers in that format. So the first question is I have to integrate x, which is an easy one. So let's just see if I use my first rule, this rule that says if you've got an x to the power n, and I've got x to the power 1, the rule says you will write down the x to the power 1 that you had. You add a 1 to the exponent, and then you have to divide by this new exponent, 1 plus 1, which is 2, and I have to remember to say plus a constant because I could have started off with a constant. So if I simplify it, it will be x squared plus a constant. If we look at the second example, it's where I'm going to use this rule because I see in this case I've got a constant 4. Now the constant will just stay as that rule indicates. So I can just write down the constant and then I can actually integrate the x to the power 2 by using this original first rule, which says write down what you have, add a 1, and then you will divide by this new exponent, and the new exponent in this case is 3, and remember to say plus a constant. Simplified, it will be 4x cubed over 3 plus the constant. Okay, let's use this rules to integrate some more. The next question is I have to integrate 3 with respect to x, dx. So the constant 3 I'll just write down. But do I have any x's? Yes, you actually have. You actually have there a x to the power 0, which is 1. But now I know what I can do. I can use this x to the power 0. I can write down what I have. Then I add a 1. And then I have to divide by this new exponent, which is actually 1, plus the constant. Let's just simplify what I have just done. It will be 3x to the power 1 plus the constant. If we look at the next one, it says I have to integrate 5 dt. So now the unknown that I actually have next to the t, 5, is t to the power 0. So since I'm working in terms of t, I've got a t to the power 0. So if I use the integration rules, I'll say write down the constant 5, write down the t to the power 0 that I have, and now I have to add to the exponent of the t a 1, and divide by that new exponent, which is 0 plus 1 is 1, plus the constant. If I simplify this, it will be 5t plus a constant. The next example, number 5, says I have to integrate 2 over x squared. Now, I have to actually look very carefully. What I know is the rule that I have says if you've got an x to the power n, which means x is in the numerator, not in the denominator, then I actually have a rule to apply. So I'll have to take this x to the power 2 from the numerator and actually put it in the denominator. And if you remember your exponent laws, it says the moment you take this power upwards, the exponent will change, its sign will change to another sign, which is negative in this case. Which means before I can actually integrate, the 2 will stay. I have to take this x to the power 2 upwards, and it will become negative 2 dx. Now I'm ready to actually integrate. So it's going to be the 2, which I can write down. I can actually integrate this x to the power negative 2 using the rules of integration, that first rule of integration. So I write down what I have. I add a 1, and now I have to divide by this new exponent, which is actually negative 1. Remember to say plus a constant. So what do I have? Positive and negative is negative 2, x to the power negative 1 plus the constant. But remember we said we are going to give all the answers with positive exponents and insert form if possible. So my final answer will be, the only way I'm going to get this exponent to be positive is to shift the position from the numerator position to the denominator position downwards. In the denominator, it will be exponent 1 plus c. So the final answer would be negative 2 over x plus the constant. In number 6, it's just actually about a notation. Don't think here the dx is really divided by the x cubed. It's just a notation to say I have an x cubed in the denominator, and there is actually just a 1 on top. So I have to integrate this. Same what we have just done. We'll have to integrate x to the power negative 3 because the x with its exponent must be in the numerator. So I can use the rule, the first rule that I have that says write down what you have, add a 1, divide by the new exponent plus a constant. So I've got x to the power negative 2 over negative 2 plus a constant. What will my final answer be? Remember, I want a positive exponent in my answer, so it's going to be 1 will be left on top. The negative 2 is at the bottom. X to the power 2 plus the constant. If we look at number 7, it says I have to integrate the square root of x cubed. Now, I only have a rule that says, integration rule that says if I've got an x to the power something. In other words, I need a base x with an exponent. I need to write this in exponent form. And I have to use my exponent laws that you have done previously in previous levels already. So I want to refresh you quickly on your exponent laws. The exponent law that I'm going to use here is this one where it says if I have something in surd form, I can actually write it in exponent form. So the base will stay the base. The inside exponent will get the top position of the fraction and the outside value will go to the bottom position of the fraction. So that's the one we are going to use here. We already used this one that says if the exponent is negative on top, in the numerator, I just take it downwards and the sign will change if the position changes. The other two that we might use is, can you still remember how to multiply powers? If the bases are the same, you will write down the base x. If I am multiplying, I have to add the exponents. If the bases are the same in these two powers and I want to divide, you will write down the base and you actually have to subtract the exponents. Okay, let's do this one. For this one, I need to write what's been given in exponent form. So it's x to the power. Now there's actually a 2 outside because it was square root. And I know it's going to be x to the power a fraction, of which the 3 will take the top position. The inside one always gets the top position and the 2 will go out below the line. Okay, now it's in exponent form, so I can use the rule that says write down what you have plus 1 and divide by this new exponent. Now 3 over 2 plus another 2 over 2 is going to be 5 over 2. So I divide it by what this gave me, which is 5 over 2. Now remember there's actually a 1 there in front. And if you use your calculator to say, but what is 1 divided by 5 over 2. Your calculator will give you that it is 2 over 5. And then what I still have there is x to the power 5 over 2 plus the constant. Remember, the moment you have an exponent, which is a fraction, then it can actually be written in surd form. So I can use this rule that I had here, just backwards, and write it in surd form. So let's do that. The 2 is on top, the 5 is at the bottom. I can write this one in surd form. The base will stay the base. The value, the top value of this fraction of the exponent will go inside. And on the outside, I will have a 2, which we don't know, we don't have to write. And I still have plus that constant. So let's go to the next one. If we go to the next one, in this problem here, I have to integrate 1, 2, 3, 4, 5 terms. Okay, remember we have a rule that says we can just integrate each one of those terms and join them with the signs that we had here. So I can't just start off and say, well, let's integrate, because I have to check, is all of these terms in the correct format? This one is not in the correct format. Both of those values, the 2 as well as the x, must be raised to the power 3. I'll have to do that first. Here I see actually I don't have a base x to the power something. I still have to simplify that to get it in that way. even here, I'll have to apply my exponent laws to simplify this so that I can have, and I'll have to, see it's in the denominator, I'll have to take it upwards. I'll have to change it to become x in the numerator. Now, let's simplify all of this so that I can try and integrate. So I haven't integrated yet, so the integral sign will still be there. The first term, no problem. For the next term, remember both values, the 2 as well as the x, must be raised to the power 3. 2 to the power 3 is 8, but the x is also raised to the power 3. In the next one, I'm going to use this rule of division that says, how do I divide powers? You have to subtract the exponents. So I see for the number part, 3 can go into 6 2 times, 3 can go into 9 3 times. So I actually have 2/3. And then x to the power what? Well, I'm dividing, so I have to subtract the exponents, and 1 minus 4 is -3. In this one, I have an x that must be multiplied with the x to the power 1/2, and then I still have the 2 dx. I'm not yet ready to integrate. Let's rewrite. This term, no problem. Next term, no problem. Next term, this one is fine because the x to the power -3 is in the numerator. That's no problem. But here, I still have to add up these. I'll have to add up the exponents to enable myself to multiply these two powers. So it will be x to the power 1 plus 1/2 is 1.5. So it's actually a x to the power 1.5, 3/2 below the line. Can we already say, but I don't want the x in the denominator, so I'm going to take it upwards. Let's immediately write it in the numerator position. Okay, then I still have the +2, and I have to integrate all of these terms. Now we can start with the actual integration. So for the first one, I write down the constant and I write down the x to the power 1 that I have. Now I have to add a 1 to what I had, and I divide by this new exponent, which is 2. 8, x to the power 3 is what I had, so if I add a 1, it will be 4 divided by this new exponent. The 2/3 is the constant that I had. Then x to the power -3 is what I had, plus 1, divide by this new exponent, which is -2. If I look at this term here, I will write down what I had. It's -3/2. I have to add a 1. Now, what is -3 plus 2? It's -3/2 plus 1 is -1/2. Plus 2, remember there's actually an x to the power 0 there, so it's x to the power 0 that I had, plus 1 divided by 1. So I actually already integrated now. So I shouldn't integrate again. It's now just to simplify it. So if I simplify this, the 2 will cancel with that 2, which will give me a negative x squared. Remember, I don't have a problem with a negative in front of the x squared. I just shouldn't give my answers, final answers, with negative exponents. The negative sign is not a problem. So here, 4 will go into 8 2 times, which will give me a positive 2x to the power 4. In the next one, I've got a negative to be multiplied with a negative, which will give me positive. The 2 will cancel with a 2, so I'm actually left with 3 below the line, x to the power -2. Okay, let's look at the next one. Positive and a negative next to each other will give me negative. This 1 here on top, divided by the half, remember I already sorted out the sign, will give me negative, it will give me -2 x to the power negative a half. And then I've got the 2x, which I don't have to simplify further. So let's quickly wrap this up. It's negative x squared plus 2x to the power 4. Plus I don't want a negative exponent, so I'll bring that x to the power negative 2 to the denominator position, and then it will become positive 2. Even here, I will take that x to the power or negative a half downwards. Now, imagine for a moment I have this x to the power a half in the denominator. Then remember, I can still write it in surd form because there's actually a 1 and a 2 outside, plus the 2x. And I actually forgot something. I have forgot to say next to all of these terms plus a constant. Plus a constant, so my final answer will have here plus a constant. Okay, and there is all those terms are integrated. Let's go to a next one. If we look at this problem, once again I've got more than one term, and I have to check before I can start with the integration, is all of these terms in the correct form? That will enable me to use the integration rules and then integrate. So if I actually start, let's check all the terms. The second term is not in exponent form. Immediately I see I still have to write it in exponent form. This one is not in exponent form, and the x is in the denominator. Even there, the x is in the denominator. So I can't just give them the answer of integration. I'll actually have to start by getting the format correctly, writing everything in exponent form, making sure that the x is in the numerator. So I've got a 4x plus 3. Now, how will I write this in exponent form? There's actually an exponent 1 inside, which will form the numerator part of the fraction. So it's 3x to the power a third minus 3 over x to the power a half plus 2 pi minus 1/3. Okay, if I want to, I can say at this stage I want the x there on top. So these are all the terms that I have to integrate. So I'm still not fine. I see this term here. The x is in the denominator where it shouldn't be, so I'll have to rewrite all of this again. So it's going to be 3x to the power a third minus 3x to the power negative a half plus the 2 pi minus a third x to the power negative 2, and all of these with respect to x is what I have to integrate. Now I'm actually ready to start with the integration. So if I start with the integration, it's going to be 4x to the power 1 is what I have, plus another 1 is 2, divide by that new exponent. 3x to the power a third is what I have, plus 1, divide by this new exponent. Now what is this new exponent? A third plus 1 is 1 1/3, which is 4 over 3. Minus 3x to the power negative a half is what I have. Plus 1. Now negative a half plus 1 gives me a half. So I have to divide by that new exponent. Plus 2 pi. What is 2 pi? 2 pi is actually a constant. Pi is that number that's saved on your calculator, 3,14 what. So 2 times that will be another number, a constant. So actually next to it I have an x to the power 0. It's just as good as I had any other constant like 3 or 5 or 10. So I have 2 pi, x to the power 0 is what I had. I add a 1, divide by 1, minus a third, x to the power negative 2 plus a negative 2 plus a 1 is negative 1, divide by the negative 1, and let's not forget to say plus a constant. So let's see if I simplify this. 2 will go into 4 2 times. I'm ending up with 2x squares. Plus, if I take 3 and say divided by the 4 over 3, I actually get 9 over 4, x to the power 4 over 3, minus, now I have to take the 3 divided by a half. Now 3 divided by a half, you can use your calculator, it's going to give me 6, x to the power a half, plus the 2 pi x. Now be careful here, I've got a negative multiplied with a negative. Negative times a negative will give me positive. I don't want that x to the power negative 1 on top, so I'm going to take it downwards, but the 3 is also here at the bottom, plus the constant. Am I done? No, because I see I have some exponents that is actually in fraction form, which means I can write them into surd form. So I still have to write them into surd form. So my final answer will be 2x squared plus 9 over 4. And I know I can write this into surd form. It will be x to the power 4 with a 3 outside. So it's the cube root of x to the power 4 minus 6, and that one can be written as square root x plus 2 pi x plus 1 over 3x. Remember that 3 is actually at the bottom, it should stay there, plus the constant. Let's look at this question number 11. In this one, let's see, I have to integrate all of these terms. Are they in the correct form? No, not yet. I see this whole bracket must be raised to the power 2. In other words, I have pi to the power x. Remember, it's just a constant raised to the power a number. And then each value in this bracket must be raised to the power 2. So 2 squared is 4. Do you know that a square root squared just gives the value below the square? So it will be only a x plus the 5t. All of these terms differentiated with respect to x. So if it's with respect to x, it means everything that's not a x is considered to be a constant. So in this case, the t is a constant, just a constant as the 5 is. So if I start with the integration, I will write down what I have, and I have to add a 1 to what I had and divide by that new exponent. Plus, write down 4x to the power 1 is what I had. Plus a 1 will be 2, divide by that new exponent. Plus 5t. Remember, next to that 5t, actually I have a x to the power 0 because the 5t is the constants. So I've got 5t. X to the power 0 is what I had, plus the 1, divide by the 1, plus the constant. So if I simplify this, it will be x to the power pi plus 1, divided by pi plus 1, plus 2 goes into 4 2 times, plus 5tx, plus a constant. In our next lesson, we'll have to look at the remainder of all the other integration rules, the remainder of the integration rules. So we'll look at them. And remember, you are welcome to use the information that's given on the screen to contact us on social media or on other platforms so that you can raise your questions. Thank you.